Transfer reactions. Many reactions involve the transfer of electrons. Oxidation-reduction reactions, or redox, which is the short form here, are reactions where electrons are transferred from one entity to another. Neither oxidation or reduction can occur without the other. They have to happen in unison. That means together. In redox reactions, one element is oxidized, which means it loses electrons, while other element is reduced, which means it gains electrons. And if you're wondering why there's a lion and an oil thing there, these are two ways to remember this idea. Leo the lion says grr. Leo stands for loss of electrons is oxidation, and gaining electrons is reduction. Leo the lion. There's also oil rig. Oxidation is loss, reduction is gain. Whichever one you want to go with it. So we're going to start this off by doing a balanced equation, which I'm going to give you. And I want us to break this down. So everything that's aqueous is going to break down into its ions. So the first line here, we're going to take aluminum and put it there. 3 sodiums that are +1, 3 chlorines that are -1, aluminum's +3, 3 chlorines again, and our solid sodium does not break up. Now we want to cancel out our spectator ions, which we have as chlorine. Those ones are going to go. So what we have left over in this reaction, so our net ionic equation is solid aluminum and sodium and then solid sodium. Now what I want to do is I actually want to look at this reaction a little bit closer. So there it is again, and what we're going to do is we're going to look at the half reactions. So let's look at what aluminum is doing on its own. Aluminum is going from the solid state to a charge of +3. So we learned earlier, or we will learn soon enough, the elements in their solid state have a charge of 0. So we've gone from a charge of 0 to a charge of +3. We have actually undergone oxidation. Oxidation is a loss of electrons. So think about this. We had a charge of 0, and then we ended up with a +3. How did we get there? Well, we lost 3 electrons. Well, what's going on with sodium here? Sodium is going from a +1 charge to a charge of 0. Sodium has been reduced. Sodium has gained electrons. It's gone from +1 to 0. It has gained 1 negative electron. So you got to think about it, this sort of mathematics is backwards because electrons are negative. So oxidation number, that's what we were looking at here. It's essentially the charge an element has. If you look this up in a book, it'll have a much longer-winded answer, but an oxidation number is simply the charge of the element. We looked at the last example. Aluminum had a charge of 0, then it had a charge of +3. Sodium was +1, and it went to 0. Now, so these charges are actually found on the periodic table, and if you recall, some elements only have 1 charge to them. That's good. And other elements have multiple charges, and that's where our work will be. It's going to be figuring out those charges. So here are some rules. When I say rules, it's kind of loosely suggestions here, but first one is an atom in the element state has a charge of 0. We've actually seen that in the last example, like sodium was in our last example, had a charge of 0 in its element. Any monatomic ion is the same as its charge, so sodium's +1, chlorine's -1, or like aluminum, if you look it up in the periodic table, always has a charge of +3. That's not going to change. The next one says fluorine is always -1. That's fantastic. Oxygen is usually -2. Can have other charges. Most of the time it's -2. And hydrogen is +1 and as a covalent compound. So essentially when hydrogen comes first, it's going to be +1. And there are some situations where it's going to be -1, but most of the time I guess it's just going to be +1 here. And we do have one exception. So that's when it's an ionic compound, right? Because calcium's +2, and then hydrogen would have to be -1. So if it's covalent, hydrogen's +1, and if it's ionic, it's going to be -1. So knowing those suggestions, we're going to look at a few examples and figure out a few numbers. So let's determine the oxidation state for the carbon in carbon dioxide. Carbon can have a couple of different charges, but oxygen only ever has a charge of -2. So what we actually want to do here is perhaps create a little equation. We're going to represent the charge of carbon with an X, and we're going to represent the charge of oxygen with a -2. So if we make an equation, it's like saying instead of carbon, we have X, and we're going to add that 2. Now we've got 2 of these oxygens, and the oxygen has a charge of -2. Now this is going to be equal to the overall charge of carbon dioxide, which is 0. Carbon dioxide doesn't have a charge. A little bit of math here. We've got +2 times -2, which is -4. And of course that equals 0. And then to solve for x, we'll take this -4 over to the other side. It becomes +4. And we have solved for the charge of carbon. So therefore, carbon has a charge of +4. So figuring out its oxidation number is that easy. How about this example? F in F2. Well, this is actually a little bit of a trick question because the first rule earlier said that anything that is in its elemental state, like any of the diatomic gases or any of the metals or anything, has a charge of 0. So F has a charge of 0 because it's in its elemental state. Now making these a little bit harder though. Mn, manganese. Manganese, if you look on the periodic table, has a whole slew of different charges. So what is the charge in this molecule here? So again, we're going to use X to represent the manganese. Oxygen always has a charge of -2. So let's make our equation. Instead of manganese, let's put X. We're going to add that 2. There are 4 oxygens, and they each have charges of -2. And this time it's going to be equal to that thing right there, -1. So a little bit of math. We want to get rid of the 8, so we'll add 8 to both sides. It's like taking it over and making it positive, so it's -1 plus 8. It looks like X has a charge, or an answer of +7. So that means manganese has where's my N? Has an charge of +7 for that one. And now we've got a full molecule here, so we want to know the carbon in this molecule here. The sodium carbonate. So if you look sodium up on the periodic table, it's got a charge of +1. Oxygen once again has a charge of -2. And carbon can have a few different charges. So let's make an equation. We've got 2 of the sodiums plus 1 carbon plus 3 oxygens, and that equals 0 this time. We know that sodium has a charge of +1. We don't know what carbon's charge is. I'm just going to leave it as a C this time for fun. And we have a -2 for that oxygen there. So we got -6, we've got +2, and we've got carbon, and that equals 0. So combining +2 and the -6 gives us -4 on that side. And it looks like carbon is going to equal 4. That's a 4. There you go. So carbon's charge oxidation number in this molecule is +4.